What's up guys, Roland here. This time on 3D NerdStop we're going to animate 3 of the pie pieces on top of the dome. Alright guys, let's take up the electronic hardware we're going to be using today. We are going to be using an Arduino MEGA. We are going to be using an Arduino Uno. We're going to be using two 4.4 gigahertz wireless RF transceivers. This is so the Uno and the MEGA can talk to each other. We're going to be using a 16-channel server driver board. This will allow us to control up to 16 servos with one board, but we're only going to be doing 3 today. The servos we are going to be using today are these. Okay, and later on in the project, just go ahead and introduce you to it now. When we're putting all the electronics into the dome, we'll actually be using this mini Nano Arduino board. So as you can see, this is significantly smaller than a standard Arduino. It's pretty small. Alright guys, let's look at some code for our Arduinos now. So we'll start off with 2 simple scripts. We'll start off with a transmitter and a receiver code. Okay, we'll put the transmitter code on the Arduino MEGA and we'll put the receiver code on the Uno. So you have the MEGA and the Uno. Okay, so the first thing we'll need to do is for the RF24 transceiver, we will need to download its class library. You will find its library here at this URL. You will also find that URL in the description down below. Okay. The next thing we'll need to do is we'll need to include 3 classes out of that library. Okay. We have to include the SPI.h, the NRF24L01.h, and the RF24.h. Okay. After you include those, you're going to have to create an object, an RF24 object. We'll call it radio. And you have to assign the CE and CSN pins. Now I assigned them to 7 and 8. You can assign them to any digital pin you want on the Arduino MEGA or Uno. Now there are other pins you have to assign, which are the SCK, the MOSI, and the MIOS. Alright, these pins have to go to the SCK, MOSI, MIOS pins on the Arduino boards. Okay, so your SCK pin on the MEGA is 52, but on the Uno is 13. Your MOSI pin on the MEGA is 51, where on the Uno it's 12, and your MIOSO pin is 50, where on the Arduino it's 11. Okay, so those pins have to go to those pins on those boards. If you have other boards, you have to find out what these 3 pins are on the board. Okay, so depending on what board you're using, you have to research its mapping of its chip and see what those pins are, because you can't reassign those pins. They are certain pins. So you have to use those particular pins for this. Alright, that being said, let's move on. The next thing we're going to do is we're going to assign an address. This is just a byte array. Okay, so we're going to have an address array here called address. That's 6 bits, and we're going to give it 5 characters. You can have a total of 6 of these arrays. Okay, so the first array in the list, we're going to make this address. Now this address can be anything you want it to be. It doesn't have to be numeric. It can be alphanumeric. You can make it descriptive if you want, as long as it's only 5 characters, because that's what you're allowed, is 5 alphanumeric characters here. Okay, then we're going to do some setup. We're going to tell the RF object to start, RF24 object to begin, and then we're going to tell it to open writing pipeline on address 0, which means it's going to be writing to this address number. So when it sends out information from one Arduino to the other, it's going to tag it saying this is the address I'm looking to send this information to. So the receiving board is looking for that same address. Okay? Then I'm going to set the PA level. This is how much power the transmitter is sending the signal out with. Okay? I have it set to min right now because, as you can see, the transmitters are set really close to each other, so I don't need a lot of power to send it between the two. But you can set it to max, which will give you up to roughly 100 meters in distance between the transmitter and the receiver. Okay, and because this is a transmitter, I'm going to tell it to stop listening, which means I don't want it to listen for incoming signals. This one's only sending signals, so that's what the write does. I opened up a writing channel to send signals out, and I'm telling it here not to listen for anything coming in. Okay? Then we have our simple loop. We're just going to create a character array. It's going to say hello world. Okay, then we're going to tell the radio to write that string, or that character array, out to that channel that I told it to listen. I told it to send to the receiver on. And then it's going to delay for 10 seconds, and then it's going to do it again. So every 10 seconds it's going to send out hello world. Okay, on the other side, on the receiving code side, as you can see, we did the same thing. We included the same stuff. We hooked the board up the same way. We created our RF24 object. I used the same pins. Okay, I'm telling it that this is the address that it wants to listen on. I'm assigning address. And you can have multiple addresses. You can have multiple addresses talking back and forth to each other with these. Right now we're not doing that. So we'll just keep going with what we got going. I'm opening a serial port basically here, so I can display the information it's receiving. I can have it write it to the screen so I can see what information the Uno is receiving. Okay, then I'm starting up the radio. I'm telling it to begin. I'm telling it to open a pipeline and read on this address. So this is the address it's listening for. This is the one it wants to see. When it receives a signal, it's going to check and say, is this the address it was sent to? If it's not, it's going to ignore it. If it is, it's going to accept it. Again, I'm going to set the level of the transmitting power, or the receiving power. And I'm going to tell it to start listening. So now it's listening, actively listening for signals to be sent to it. Okay? So down here inside the main body loop, which is the code that it runs constantly, this only runs once, the setup, and this it continually runs. It's going to say, is the radio available, which means it's listening for incoming data. I'm setting a variable up, make it blank, then it's going to read from the radio if it received a signal, and post the information it received to this text variable, and then it is going to print that text variable out. Okay? Makes sense? So if you want to see this in practice, we will turn on our two Arduinos. And the first thing we will do is we will set up our transmitter, which is a Mega. And it is on my computer right now on COM 5. So now I will upload this sketch to it. So now I am uploading that to the Arduino MEGA. As you can see, it is done uploading. So technically this is transmitting right now, there's just nothing listening to it. So then we will come over here and we will connect this one to the Uno. It's on COM port 4 on my computer. And I will now upload this sketch to the Arduino Uno. And as soon as it says it's done, okay, now we'll come up here and we'll tell it I want to listen to the serial monitor. This is listening to the port that I told it to listen to. And as you can see, every 10 seconds, which is a wrong time. There you go. As you can see, every 10 seconds it's receiving hello world. So the Uno is transmitting to the, the Mega is transmitting to the Uno every 10 seconds hello world. And you can see that we've got it working. Alright, now let's spice it up a little bit and let's add some buttons to the Mega, so when I push a button it will transmit data when the button is pushed. So let's do that next. Alright guys, now what we're going to do is we're going to add 3 buttons to the process. As we can see over here, I've got 1, 2, 3 buttons added. I know they're kind of hard to see, but I added 3 buttons to the process. Now we're not going to change anything on the receiver side, so the receiver code's going to stay the same for right now. The only thing we're going to change is on the transmitter side. And on the transmitter side, all we're going to do is, you can see the beginning of this is identical to what it was. The only thing we did was we added the 3 buttons. We added them to pin 2, 3, and 4, 1 to each button. So we create a constant, and it's an integer. So basically I'm saying that this button name is assigned to this pin. This button name is assigned to this pin. So that's all these are doing, is assigning the button names to pins. Alright. Then down here all I'm doing is recording what state the button is in. So right now technically the button is in the low state because there's not power going through it. Okay, so that's the way I have the button set up, so the buttons are technically off right now. Alright, so the next thing we do is we do the same thing with the the transceiver. Sorry, with the transceiver we did before. We're going to start it up. We're going to tell it it's writing to this particular pipeline with this address. This is the amount of power we want it to transmit it with, and we don't need it listening back for information. At least not right now, we don't. Okay, then we're going to turn these pins, which is pins 2, 3, and 4, into input pins. So these pins are going to be listening for data coming in on them, or power coming in on them. Okay? So then basically all we're going to do is I'm going to set the button state to the digital read of this pin, which is pin 1, which is button 1, which is pin 2, which is pin 2 on the Arduino Mega. Okay? And then it's going to say, well, if the button state changed to high, which means it doesn't equal 0 anymore, it's not low, it's now high, then it is going to create a character string and send this string to the Arduino Uno. And then it's going to check button 2 to check its state, then button 3 to check its state. Okay? So while the button is held down, the state will be high, so it'll continually do this. When you release the button, the state will become low, so when it reads here, this will no longer be true and it won't do anything. Okay? So to prove this, we'll fire everything up and send everything over real quick. Alright, I did go through and wipe out both scripts off both of them, so we have to go back and turn the scripts back on. So we have it set up for the Mega here. So we'll go ahead and transmit this script to it. We'll upload it. It's uploading, it's done. And then we will come over here and we will change this over to the Uno. It's on port 4. And then we will upload this. Here and we'll tell it we want it to listen. So as we can see right now, it's not showing anything because I haven't pushed any button. So if I push button 1, if I push the first button here, it starts putting 001. If I push the second button, it does 101. If I push the third button, it does 100. So as you can see, it's only adding to it when I push the button. As you can see, it's not adding anything right now. It's just sitting there. When I push the button, it'll add. But the one problem I'm seeing with this, I don't know if y'all are seeing it, is it just continually runs real fast. So I'm posting the same number over and over and over and over and over and over again. Well, when I do this, I want it to transmit the number one time, and then the other Arduino will take that and say, oh, this is the code I was sent, this is the operation I'm supposed to do. So let's change the transmitter code one more time to only do that, to where when I push the button it only sends it, when I push the button it only sends it one time. So let's take a look at that real quick. So in order to do that, we'll just come over here. I have a third script for us. And we will just stop this one real quick. Okay, so we have our third script here. This script is pretty easy. It's pretty much identical, except for I added a button flag here. And basically what this flag is it's really simple. It's going to come in here to an if statement, and it's going to check to see what the state is. Originally I'm going to set the flags to 0, which means it has not been sent. Okay? When it runs through the code, it's going to check here. It's first going to check the button state, make sure it's high. If the button state is high, then it will check the flag state. Has it been sent yet? No, the flag says it hasn't been transmitted yet, so then it's going to transmit the code, and then it's going to tag that, it's going to change that flag to a different value, to a 1 in this case, which tags it as sent. Okay, and then it's going to go do the second for the second button, same for the third button. Alright, and if you continually hold down the button, the second time it comes up and goes through this loop, it's going to say, okay, well the button state on 1 is still high, but the flag is no longer equal to 0, so it's just going to skip out of it, and it's not going to do anything. And it will continually keep skipping over all of this here until you let go of the button. When you let go of the button and the state drops from high to low, then it will come down here and say, okay, the button is not pressed, and the flag now equals 1, so I'm going to change the flag state back to 0, which means not sent. So that's what we did on all 3 buttons. So now when we upload all this code, which we can do, we will upload this to the Mega on port 5. Oops, come on, there we go. You can upload all this. Okay, so now we've got all this ready to upload. We're not going to change this over here, but what we do have to do is tell it we need to listen to this board. So it has to be connected to the board. Okay, and the only thing I'm going to do is push the reset button so it resets the script on it. So now if I come up here and I get the monitor, it's blank. So now if I push button 1, it gets it 1 time. And I push button 2. Oops, button 2 must be plugged into the wrong, must be hooked up wrong. Hang on. Uh-oh, what did I mess up? Oh, sorry, my bad. I have my string wrong on button 2. It was supposed to send a different code. Let me check button 3. Button 3 is correct. I somehow messed up and typed the same thing in there twice. So, that being said, we will kill that real quick. We'll switch this back over to the Mega. See, everybody makes mistakes. This is why we test things over and over and over again. Okay, we will re-upload that to the Mega. Upload done. We will reconnect to the Uno. Yeah, in order for the serial port information to work, you have to be connected to that board. I'm going to tell it to restart real quick just to make sure it does it, which shouldn't take but a millisecond to do. Okay, so let's try that again. So we push 1, we get 1. We push 2, we get the code for 2. We push 3, we get the code for 3. If I push 3 a bunch of times, now as you can see, I can't rapidly push it because it has these delays in it. And the biggest reason I have the delays in it is these buttons are not that sensitive, or not that great of buttons, I guess I should say. they're real easy to push down on it and to think you're doing something like this, where you're just clicking it. So these buttons do better if you push and hold, and I have it to where there's a delay in it so it won't continually do that. So as you can see, I can control, by pushing the button. What it sends, and it only sends it one time. So that's great. That's what we were looking for. Alright, so now what we need to do is let's add some servo motors to this and get the servos moving. Alright guys, as you can see, we've changed our layout a little bit here now. Now we have 3 servos, which represent the 3 flaps that we just put on our dome. Okay. We also now have the controller for the servos. We also have a voltage regulator here. This lets me reduce this 12 volt battery down to 5 volts, because that's all you can put into here is 5 volts. I believe it's 5 to 6 volts you can put in. And this is just a little meter saying how many volts are going from here to here. So when we plug this in, kind of hard to see, hopefully you can see it, but this says it's putting in 5.16 volts. Okay, so that's how much power we're putting into here, and this power supply is what's controlling the servos. Okay, there is a 5 volt lead coming off of here into the board, which is what powers the board, if that makes any sense. So the servos is running off of the battery, where the board is running off of the Uno. Okay? So, that being said, the only script we're going to change this time now is we're going to flop over. We're going to change the receiving script. We're going to leave the transmitter the same as we had it last time. And this time we're just going to change the receiving script. Alright, so to start off with it, the very beginning is the same. We're including the same classes. But now that we have the 16 channel servo driver, we have to include its libraries. So here's the URL to it. It'll also be in the link in the description down below. Okay, and it has certain pin setups we have to use as well. Okay, on this one we have to use a ground. Okay, and then we're using 5 volts, which I said, so we have ground and 5 volts going in, and then we have an SCL and an SDA. Okay, and on the Uno, this is 5A or A5 pin and A4 pin. These are analog pins. Okay, and these have to be set to these 2 pins. Okay, I'm honestly at the moment forgot to look up what pins it is on the Mega. I'm going to guess it's real close to the same. It's going to be in the analog pins, but it should be something you can look up online and find out. Okay, so what we're going to come down here and do is the first thing we're doing here is we are importing the classes, for the 16 channel servo controller. So we have to get the right H and the Adafuit-PWM-Servo-Driver. Okay, so once we include those libraries, the next thing we're doing is we're basically setting up the servo drivers to the board configuration. I'm not honestly, okay, this is kind of hard to explain. You can actually take these boards and daisy chain them, so have multiple boards in line, and this whole thing right here has to do with addressing those alternate boards. Since we're not doing that, I don't think I'm going to be doing that at any point in time during my project. The default is to just set it up this way. So this is basically just telling this board what its address is, or it's telling the Uno what the address is. So when the signals are sent out, this board is listening for this address set. So if I had a second board, I'd have to give it a different address, which is done by soldering some joints, some things down here, which then gives it different address codes. So you would have to then address it by that address code you gave it. I don't know. I haven't done it, so I haven't tried assigning anything other. This is the default. I'm only using one board. When you're using one board, this is the default you use, so this is what I'm using. like I say, there are a lot of people out there that know a whole lot more about this than I do. I only know a little bit. Okay, now on servos, these particular servos go 180 degrees. Okay, and they work based on a pulse width. So based on how long and period of time they are given power in a pulse is how far they will move. Okay, and we can designate where they start and where they stop within that range. So in order to get full motion, the whole 180 degrees they move, on these servos it actually happens to be roughly for the minimum distance, which is when it's at its lowest point, is 115 pulses, and its maximum is 600 pulses. So that's just telling it what position it is in the servo. I'm not exactly how that works. That's just the basics. You do have to go in for your servos and figure out what the best one is depending on your servos. Even these don't necessarily all fall in the exact same range. Luckily they're really, really close. And I'm sorry I'm doing a terrible job explaining on how this works. There's a lot of stuff out there about it, and you'll be able to get better information by listening to somebody else on this. I just made it work. I'll be honest with you guys. Now I did come up with a constant here, which is when the flaps are open. This is the open angle, and basically what I did is I mapped. Okay, I said 90 degrees is how far I want the servo to turn from 0 to 90 degrees. That's how much it'll need to turn in order to open it. And I'm saying that how it comes up with that information on the map is it says, well, I'm going to take 0, which is the minimum servo distance, and 180, which is the maximum servo distance, and it does a mathematical calculation when I say 90 here, and it figures out what the number needs to be between these two numbers to be a 90 degrees from where it starts. I hope that makes sense. And then the closed flap, I'm telling it is at 0. So when the flap's all the way closed, it should be at 0. Now, when we actually hook this up to the dome, that may not be true. Because what's 0, if you're thinking of an angle is 0, which means it's at the lowest point, we're at the bottom of the servo turn, it's as far as the servo will turn one direction. The 0 may be too much. You may be pulling the door closed too tight, so I have to set it to a different code so it sits at a slightly different angle. We'll figure that out when we get there. As soon as we hook that up, we'll start playing with that. So we would play with these two numbers to get the flaps so they open and close the full distance open and the full distance closed without putting any strain on the servo motors doing it. Alright, so here I'm creating an instance of the radio and the address that the transceiver is receiving on. And then I'm setting a flap status. Okay, this is stating that the flaps are all closed right now. Okay, so basically what I'm doing is I'm writing blocks of code based on what pushing is pushed to what action is going to happen. The first time they push the button, the servos will open the flaps. The second time they push the button, the servo will close the flaps. So this will allow us to create many different patterns. I have 3 buttons, so I'm going to create 3 different patterns of how they'll open, and we'll go through how all that works here. Okay, so we're telling the PWM, which is the circuit board here, to begin, and we're telling it the frequency that it's going to move the servos at is 60 Hertz, which for most servos do run at 60 Hertz. Most of them. There are some out there that run it more. The majority of them do run at 60 Hertz. Then we're going to fire up the radio and tell it to listen. Just like we did before, it's listening to the same channel, it's listening for the same thing. Okay, the next thing we're going to do is we're telling all of the servos to make sure the doors are closed. So we're giving it a default state of closed. So if a flap was partially opened or whatever, this would close all of them when the Arduino fires up. Alright, the next thing we have here is we're listening for a radio transmission. Okay, just like we were before, except for now we've replaced all of the code in the middle. Instead of just writing it out to the screen, now we're actually going to make the servos do something. Okay? So as we can see here, we're listening for it, we get the information. And then what I'm doing is I'm looking at a specific character in this string of characters. So I'm sending 3 characters over. So here on the first one, what I am looking at is the 3rd character in that string. So if I'm sending over 001, I am looking for the 1. Okay? So I am telling this here by telling this text 2 equals 1, because this is a 0-based language, the first character is actually character 0, the second character is character 1, and the 3rd character is character 2. So I'm telling it to look at the 3rd character.
I don't know that.
Sorry. So I'm telling it to look at the 3rd character in the string and determine whether or not it is a 1. So if it is a 1, then it's going to look and say, well, are the flaps open or closed? So basically it's asking here, are the flaps closed? Yes, the flaps are open. So what I want to do is I want servo 1, which is, again, the board is a 0-based. So the first servo is servo 0, and I want it to move to the open angle. Then I want it to delay for half a second. And then I want it to go to servo number 2. Okay? And I want it to open it to the open angle, sorry. Then it's going to delay another half a second, and then it's going to tell it to do it to servo 3. And the reason I have the delays between them, because if I don't, they would all 3 move at the same time. So this is opening 1 flap at a time. Okay? Now, if the flap state had been set to 1, which is what it does here, once it opens all of them, it sets the flap state to 1. So now all the flaps are open. Okay? So next time you push a button, if it happens to be the first button, so it sends the code 001, which means the 3rd character is a 1. Alright, then it would say, okay, well, is the state a 0? No, the state equals 1, because the last time we ran to it, we set it to a 1. So because it is a 1, now I know the flaps are open, so the else is taking care of that. And now it is going to close the flaps. And it's doing it in reverse order. So I'm closing the 3rd one first, the 2nd one second, and then the 1st one last. And then I'm setting the flag back to 0, stating that all of the flaps are closed. Okay, and then I'm having it delay. And then I'm doing it again, but this time I'm looking for the 2nd button to be pressed, which is what it's doing here. It's looking for button 2 to be pressed. And now I'm looking at the 2nd character, the character in between the string. So I'm actually looking for this code. So I'm looking for the middle character here to be a 1. Okay, and if it is a 1, then I'm saying what's the flag state? Or the flap state. They're closed right now, so I'm going to open them all at once, which is what this does. This opens all 3 flaps at once. Then it'll pause for 5 seconds. It'll set the state of the flags. It'll pause again for, a half a second. And then it'll continue on. Alright, now, if the flag state had been, of course, when we set the flag state here, the 2nd time I push that button, now it's going to come back and close all of them. And basically all I've done is create 3 patterns here. So when we go on to the 3rd pattern here, as we can see, the 3rd pattern is it's going to open the middle flap, and then it's going to open the 2 side flaps. So it's opening flap 2 first, and then 1 and 3 at the same time. And then it's going to do the same thing with closing them. Now the nice part about the way I wrote this, if I wanted to, I could open them by pushing button 1, and then close them by pushing button 2. Okay, so I will demonstrate how all this works here in a minute. And I know I don't know if all this is making sense or not. It took me a while to figure all this out, but hopefully what I'm explaining makes sense. So let's fire everything up and get it working. First thing we'll do is we'll power up our Arduinos. We will then send our Mega first. Or actually, sorry, I don't need to send the Mega. The Mega is already good. We can send this code over to the Arduino Uno. So we'll upload this script. So now if we watch, if I push button 1, yeah, push button 1 again. So 1, 2, 3. Push it again, 3, 2, 1. If I push the one in the middle, all three of them move together. Push it again, all three of them close. If I push the last one, the middle one opens, then the two ends, and I can close it the same way. I can also go where I open it, and then I say, okay, well, all three of you close at once. So this allows me to put pre-programmed patterns in based on a button push for how I want to animate the R2 unit. Okay, so now we've seen it here, we've seen the simple demo of it there. Now let's see if we can actually hook this up. It won't be installed permanently, just see if I can actually get it, let's see if I can get this board hooked up inside the dome so we can actually see the flaps open and close. Alright guys, so I've got the servos hooked up inside the dome to the server controller board. And when I did this, I discovered that my servos, I guess you would call them, are upside down, to where I had the closed flag at 0 and the high flag at like 90 degrees, where it had to be the other way around, where the closed flag has to be closer to 180 degrees, and the open flag would have to be closer to, well, 90 degrees still. But the closed flag had to be the other end of the spectrum. So if you think of high and low values, the servo is set up so high is closed and low is open. So that's the way they fit into the dome. So just a little note for you there. But what I had to do is I realized once I had hooked up and ran the code that the servos aren't identical, which I know they're not. I mean, they are all the same manufacturer, they're all the same brand, but no two servos are the same. So what's 0 on one may not be 0 on another one, and it can be off by a tiny little bit, and it can be off by a whole bunch. So because of that, I created a positioning for open for each individual servo, and a positioning for closed for each individual servo. And as you can see, like 1 and 2, the open is 75 degrees. So that's good. But the closed on 1 and 2 are completely different. One's 170, one's 178. As you can see, the open on 3 is different, but on 3 for closed is the same as 1. So that tells me that the servos are not exactly the same. The way the servo arms attach over the toothed driver that sticks out isn't the same on each one. So it makes for different values, plus they're not guaranteed they're set in the exact same position. The end stops might be slightly different in one to the other because it has a little plastic burr on one and it doesn't on another one. There's a lot of different reasons why the servo can be slightly different. And it could also be just simply that when I glued the hinges in, they're just off a tiny little bit from each other as far as positioning up and down, which could affect, you know, how it opens and closes the door and what it needs to pull it closed and what it needs to push it all the way open. So just that tiny little bit of difference can also make a difference on it. So in order to counteract that, I just assigned each one individually its own value. Okay, so we didn't change anything else on the code except for these values here. Okay, we created these and I went through and found the correct values for open and closed. Okay, and then the first thing I'm going to do while the code is doing its setup is I'm going to close all the flaps so they're always in closed position when you first turn on the Arduino. Or when I first turn on R2D2, they will always close. If they're open or partially opened, they'll always all just close, so they're always in the closed position to start with. Okay, so I have my 3 scripts where I open one at a time, and then I close one at a time. And actually I have this backwards here. This should be 3, 2, and 1. Okay, and then I have it where it opens them all together, it closes them all together. Then I have it where it opens the middle one and then the outer two, then it closes them. Okay, so let's run through each one and see what it looks like. So if we run through one, each one opens one at a time. So we go 1, 2, 3. And if we close it, it goes 3, 2, 1. Alright. So if we go through the next set of code, we're going to open them all at once. And then we're going to close them all at once. Alright, and if we go through the last one, we're going to open the middle one and then the two outer. And then we're going to close the middle one and then the two outer. Now the cool part is at any point in time we can change. I can open them all at once and then close them 3, 2, 1. Or I can open them 3, 2, 1 and then close the middle one and then the outer two. So it allows me a lot of different combinations to make it work. And as you can see, it works really well. So I think it works well. I like the action on them. It looks good. It reacts well to every clicks. The signal is sent from the transmitter or the transceiver, but transmitter to the receiver inside. And as you can see, it works. Thank y'all for watching. If you like what you saw, please like and subscribe. Please leave a comment down below. I'd love to hear from you. Until next time, have a great day.